Hello everyone, welcome back to another video on Python basics. And in this video we'll continue Python functions and we'll see some more concepts related to Python functions. So I have created this Notion page for you guys. So this is the agenda for today's video. So we'll continue with Python functions and we'll cover variable args, variable keyword args, correct parameter ordering and annotations. If I just go to the first link, so these are the notes. I will share them in the description. You can take it from there. So without further ado, let's go to our PyCharm and let's see what are these concepts and how we can use them. So our first topic is Python args. So args is nothing, it's a parameter that you can pass to your Python functions. So let's take our Python function. So I'll name it Python function and I'll give it a parameter star args and I'll just print this args. So what does it mean? So args basically help you to pass any number of arguments to your function. So these are not just any arguments, so these will be positional arguments. So if I pass on 3 positional arguments, here you can see we have only one param, right? But that param is star args. So you can pass any number of positional arguments. And if I just run my program, let's just run it. You can see we have printed all of them, right? So one key concept here is when you pass variable number of arguments, they are all passed as a tuple. Okay, so in order to see that, so what we can do, let's try to print the type of the args. Okay, if I just run my program, you can see it's a tuple. So when you pass n number of arguments to your function here, so they are all compressed into a tuple and passed on to your function. So one key thing to note here is these are all positional arguments, right? So they are not keyword arguments as we saw in the last video. What I mean by that, let's try to change our function definition. I'll add 2 more parameters here, a and b. As you can see, my function call has automatically changed. Now it's expecting first 2 arguments that I'm passing as positional arguments, a and b, and the rest of them are variable number of arguments. If I just run my program, you can see your arg size has decreased. Only 3, 4 and 5 are the last 3 ones that are passed here, right? But before that the positional arguments have taken place. So one value is assigned to A and 2 is assigned to B. One key thing to note down here is you can see how they are represented while calling the function, right? First you pass the positional arguments and then you pass the variable positional arguments. Okay, so now there is a concept of packing and unpacking. When you call the function and you have in the function definition variable arguments, right? So it's packing it to a tuple. But how does unpacking work? Let's take an example. I'll just paste the code here. So here you can see there is one function add. It takes 3 parameters a, b and c. They are all positional parameters. Okay, and there is one function wrapper. It takes variable number of parameters. Okay, so now when I call the wrapper, I pass 1, 2 and 3. So as I mentioned in the function definition, star args packs your arguments into a tuple. So here these are all tuples. Okay, so let's just try to print the type here. If I just run my program, you can see it has received 1, 2 and 3 as a tuple, and you can see we are typing the type also, right? But when calling the add function, it's expecting all three integers separately, not a tuple, right? So when you give star args while calling your function, it will unpack them from the tuple to individual elements. So that is why it's adding all three elements separately. If you don't believe me, what we can do, give it like this. So now what will happen if I just run my program? You can see there is an error here. So it's expecting 3 positional arguments, but we have given 4. Why? Because it's unpacking it here. When you give star args, we have passed 3 of the arguments and we are adding one more here. Okay, so this gave an error. So what will happen if I just don't give the star here? You know args is a tuple, right? And here it's expecting integers. So if I just run my program, you can see it's missing 2 positional arguments. So it's complaining because it's passing here a's value is, let's try to print here. If I just print a here, so you might have guessed it right, it's passing a tuple. As you can see, a tuple. Let's just print this one. Okay, so it's not printing anything because it's not even reaching there, right? But you are passing a tuple and the whole tuple is passed as a. Okay, so now it's expecting 2 more values as positional arguments. It's saying you haven't passed them. But if you just put star here, it will unpack them and convert this tuple into 3 separate values and pass to this function on line number 2. If I just run my program, you can see a is 1 now, and b is 2, and c is 3, and so on. And now then we are just adding them. So in real world, it's just used when you don't know the number of arguments that you will be expecting. For example, you are trying to write logs in a file, right? You don't know how many logs will come. So if you are creating such a function, you can basically pass variable positional arguments. So just give star args as the input, and you can keep adding the log. Okay. So what is kwargs? Similar to args, so it's like variable number of keyword parameters. Okay. So if my function is keyword args, and I just try to print everything, so autocomplete is really good here. If I just run my program now, you can see in this what's the difference. So now we are passing variable number of keyword arguments, all right, and I'm printing it here. You can see they are being printed here, and they are packed into a dictionary. All right, so here when we were using args, the positional arguments, not the keyword arguments, they were passed as a tuple, right? But the keyword arguments are passed as a dictionary. So that's the key difference. So if you don't know how many keyword arguments you will be expecting, basically you can use this. All right, but there is a pitfall here. If you're writing a API, right, let's say you have an object. So we'll cover object oriented programming later, but let's say you create a user. All right, let's say you create a user. It has name and age, right? So this is a fixed what do you call it, blueprint for this user, right? So if you like try to get, okay, let's try to write the example only. Print user keyword args, all right, and then you are trying to pass print user a, b, and c. So let's try to give some reasonable names here. Let's say name is equal to John, age is equal to 20. All right. So now you are using keyword arguments, right? So one drawback here you can think about it. So like if you have a user, predefined user, right, it has two properties, name and age, right? So if you are using a variable keyword argument here, you can pass anything to this function, c equal to 30, right? So what will happen now if I run my program? I'll just comment out this one. You can see on line number 9 you have printed your user name John, age 20 and c equal to 30 and type is dictionary. So now you can see in terms of user, c equal to 30 is absurd, right? It's not a valid property for a user, right? So when you are using keyword arguments, you have to make sure you use them in such a case which doesn't break the contract, right? So you are breaking the contract. Your user was supposed to have only name and age, but here you just pass one more keyword argument c, and you can pass so on many of them, right? So it's not a good design. So design wise, like it's not good, but it can be used when you are writing some abstract method, right? When you don't know the number of arguments, but then you can later define a concrete definition of that function. If you are writing an abstract function, later you are defining a concrete definition, and then it's useful. Otherwise it can be a mess. So be careful by using variable keyword arguments. So one important thing to keep in mind is whenever you are passing different type of arguments to a Python function, a sequence should be always followed, okay, while calling that function. The sequence is, first you need to give the positional, then you need to give the default positional, then the variable positional, then keyword only, and then the variable keyword only arguments. So this is a sequence that you should respect, otherwise you will receive some syntax or compilation errors. Just keep this in mind, and this slide will be there in the description. You can try to write your own function and try different combinations for passing the arguments, okay. Let's move on to the next topic, that is the annotations. All right. So what are annotations? As the name suggests, so they are like hints, okay. They are way to specify your data. So let's take an example. If you want to define a variable x and assign it value 5, this is how you do it, right? But if you want to use annotation, you will give the type of x here after a colon, and this is the annotation, okay. So what it means is you are explicitly telling that I want the x value to be a number, right? You can also give str a string. You are explicitly saying, you can see it's saying it's expecting a string, but you are giving an integer, right, a number. So that is why annotations are used. They help you to make sure while debugging you are making less mistakes, so your code is more error free. So it makes your code more readable, and if somebody else is reading your code, they will know, right, what kind of data type your function is expecting. So let's try to run some more examples. Okay, so one thing to keep in mind is the annotations do not change the behavior at runtime. All right, so they don't. Let's say I want to assign x a value John here. So x was integer, but I have assigned a string here. So what do you think will happen if I try to print it? As you can see, it has successfully printed it. So we are able to reassign x a string. So the runtime behavior is not impacted by the annotations. Okay, so they are just for reading the code, and in some frameworks like fast API, so it's really good to use the annotations. They help you to keep your code clean so that the further errors, the runtime errors, can be avoided, okay. Let's take one more example. Let's say you are defining a function, right. You want to define the annotations saying I want a parameter a whose value should be integer, a parameter b whose value should be string, and this function should return a list. All right, so the definition, the body of the function doesn't matter here. So what I'm trying to show you, if you just call my function and pass 1 and 2, so it will take b as a string and it will take a as an integer and it will try to return a list. If I just run my program, you can see a and b value are fine. Let's try to print the type. I haven't done that since it doesn't affect the runtime, so the type should be automatically identified as an integer. Let's see. Yeah, you can see the types are identified as integers even though we are specifying here that we want b as a string. So this is a usage of annotations. All right, so annotations help you to improve the readability of your code and static type checking, and in some frameworks like I told fast API that we will be seeing in the future, annotations are used. So there is a special annotation called optional. So as you can see in this greet function, so you can import it from the typing library. So you can see in this greet function we are expecting a name and its type is optional as string or none, right? And we want to return a string. So what will happen in this function if I run my program, since we are not passing any argument, all right, so it will take it as none and print hello guest. You can see, but if I pass on a string here, if I just run my program, you can see we are printing hello John. So annotations, as I said, they are more for readability, and in some large applications, right, it helps you to maintain your code really well. So you will see when you are using some advanced version of Python, and if you see any API written in Python, you will see annotations are being used. So that's all for today's video. I'll try to post some exercises in the description. You can go to my GitHub and try to solve them. If you face any issue, just let me know. I'll try to solve the solution in the comment section. So thank you for watching this video. Please give a thumbs up and consider subscribing to this channel. Thank you.